Thank you, everyone, and thank you for that great introduction. Before we get started, just want to make sure, thank all the organizers. I help run a Java users group in Kansas City, where I'm from, and that's a lot of work, and I can't even imagine all the work that goes involved in organizing and running a conference. So definitely thank them for that, and also, of course, thank the sponsors by checking out the booths out there, because also that helps support and keeps the cost down for attending these conferences. So, as mentioned, my name is Billy Corando. I'm a developer advocate with IBM. You can follow me at Billy Corando on Twitter, and also you can feel free to email me at williamcorando@IBM if you have any questions about this presentation, or you can think of something later on. Definitely feel free to reach out. I will definitely get back to you. So, my presentation, 15 ways to optimize Spring Boot for the cloud. So I initially was putting this presentation together for a conference in the United States called DevNexus, a really great conference that if you ever get a chance to go to it, I know that's a long trip, but it's really well put together. And so it's like, okay, I have a huge amount of experience with Spring and Spring Boot. I've been doing Spring for about 8 years, Spring Boot for about 4 or 5 years, and a good amount of experience with cloud. So I'm like, okay, I can put together 15 ways to optimize Spring Boot for the cloud. And so I submitted that, got selected, and then started actually working on the presentation, and actually ended up coming up with a couple of extra ways to improve Spring Boot for the cloud. So you actually get about 20% free with this presentation. But before we get into the meat of this presentation, I just want to take a moment to talk about a couple of things. So the team I'm part of at IBM, we recently started putting together a newsletter, a Java newsletter. I did a last month's newsletter in which I talked about test containers. But anyways, it's a great way to kind of keep up on what's going on in the world of Java. We kind of put links to events like the Great International Developer Summit, or what stuff that's kind of going on in the Java world. So definitely check it out. Also, we also have some great documentation on how to build and run applications in the cloud. Whether you're using IBM Cloud or any other cloud provider, we're obviously using IBM Cloud as the implementation detail for our documentation, but a lot of the principles would relate regardless what platform you're using. So also check that out if you're kind of looking to get into the cloud world, which I'm guessing many are because, well, you're here. So, optimization, what does that mean? So, optimization isn't just a single goal. It's not like these are the 3 steps that for every single application you're going to do is going to get optimized. It's what optimization is going to vary from application to application, and you're never going to get to the point to where an application is quote-unquote fully optimized. Optimizations are going to be changing based upon customer needs, business needs, and just overall demands for your organization. So you're never going to get to a point to where you have your application optimized and you just can kind of be done with it. And there's just many different ways on what you can optimize upon. And kind of to that end, so a lot of this presentation, it's going to, kind of how I ended up developing it, is it's very much about maturing in the cloud. So if you're kind of, how many people here are like pretty much all like running their applications in the cloud? A couple? A few? Great. So, definitely also get some benefit, but this is also really a great way kind of, if you're thinking about getting into the cloud, both how to get there and then how to start developing and changing applications to really start taking advantage of the cloud. So what are some factors I want to put on how you can optimize your application? Well, I think one of the biggest and most important ones we have to start with is observability. How are we going to know how to optimize our application if we have no idea how it's behaving in production? So one of the first things we have to do is optimize how we can get information out of our application, understand what's going on right now, how much memory it's using, how long it's taking to process a request, how long, or maybe what else it's calling to understand where errors are happening, where slowdowns are happening, or maybe what is using up a lot of resources. And we can then take that information and say, okay, this is where we should start working on optimizing to get better. One of the best ways to perhaps improve the performance of the applications is to make them more resilient, to make them so they won't be crashing so often. You could have applications that are extremely efficient and respond very quickly, but if they're crashing all the time, well, then that doesn't really help you too much. Increasing your uptime, that's going to be a great optimization strategy, because if your application's down, you're still having to pay for resources to host it, and of course you're going to be frustrating your customers most of all, because it's either down, not working, or just a difficult and frustrating experience. So we're going to be looking a lot at resiliency, which is how to limit problems when they arise, and also just how to make it so customers and clients maybe aren't that aware when issues are happening. Another issue is scalability. And scalability works in two directions. There's both the ability to quickly scale up to a lot of demand, but you also want to scale back down when the demand has dropped. Because if you have hundreds of maybe dozens of instances of an application running, but you only have a very low load at the time, or customer traffic coming in, you want to be able to kill instances so you can save on money for your organization, because you don't need to be running all that additional capacity. Security. So I think security is something that for a long time we maybe shouldn't have cared or didn't care much about it, but there's been many recent incidents of places like, I don't know if it's as well known here, but like Equifax, which is a big credit rating agency in the US, had their information hacked, which exposed a lot of sensitive information for a lot of people who use that in the US. But even if your application, like, hey, we don't really have that important information, but if you have emails, usernames, passwords, you actually have a lot of very valuable information, because a lot of times users will reuse, either usernames or emails, and of course passwords between the different sites they use. So then by you being vulnerable to being hacked, by perhaps storing your passwords in clear text or not having good security practices, that could then impact your customers for other applications and other services they use. So it's really important as developers that we really seriously consider security and try how to implement it properly to make sure we're holding our client and customer information in confidence. So efficiency, this is maybe what most people are initially thinking of when it comes to optimization, how we can make the most out of the resources that our company is using, or our organization is using, reducing memory usage, reducing CPU usage, so that way we can just get more and process more traffic with less capacity. And of course, what this ultimately comes down to is money, how we can do more with less. And then finally, this kind of comes to the last thing I was talking about initially, with how optimization isn't an end goal, it's an ongoing process. So how can we have a system and an architecture where we can continually improve, experiment on our applications in production and feel safe about doing that? So a lot of this presentation, I've kind of read a few books over the years. Looking back, it's kind of you read a lot, but don't necessarily feel like you have to be reading all this immediately kind of coming out of this presentation, but a few of them that kind of built the basis of this presentation. So one of them is domain-driven design. So domain-driven design can be very helpful for how you should break down an architecture, your applications, your microservice architecture, for example. Domain-driven design can really kind of guide you in how those lines should be broken up, and as well as just a really great way to how to design applications, so then other developers and other business people can actually look at and understand what your application is doing. You're not having just a bunch of abstraction layers of just very generically named classes and constructs that make it very difficult to understand what your application is attempting to accomplish. Another book, Continuous Delivery, has probably done more to change my views on software development than any other book. And so a lot of what continuous delivery is does anybody actually kind of do continuous delivery or continuous integration of their organization? A few? Great. So you kind of maybe already know a lot of the benefits, but continuous delivery is setting up a system to where you commit, and it's going to run through a bunch of automated processes to move your code to production, or at least a near production environment. And I kind of remember first hearing about continuous delivery in blog posts years ago. And I was thinking, oh, that sounds cool, because there's like Amazon or Netflix or Facebook or something was like deploying like just dozens of times a day, and the organization I was at that time, it would take weeks or months to plan out a deployment. So I'm like, oh wow, being able to deploy all these times in a single day, that sounds really cool. And while that is really cool and that's really nice and can be great for when you're having a production issue to be able to deploy that quickly, really, in many ways, continuous delivery, the least interesting part is the speed to deployment. What's really great about continuous delivery is the automation, both in your deployment and also when you're testing, you get a really great auditability and reproducibility. You're not dependent upon these manual processes to go back into regression testing or how to deploy, because people, humans, we can make mistakes even if we're not intending. Someone can be pointing at the wrong environment when they're running a test or running a script that then causes something to go wrong or go untested, goes to production, that then causes an issue. And even continuous delivery, like some places maybe if you're heavily regulated like health or finance, we'd be like, hold on, we can't deploy to production that quickly. But actually this process is actually way better than doing manual processes, because you can actually see like, yeah, we did run these tests, we did go through these steps, because you actually have it all scripted out, and you can kind of log and show that behavior to show that you actually went through these processes. So it's actually really great for highly regulated industries to be doing continuous delivery to do these automated processes. Then there's also release it, and that release it, that touches a lot on resiliency, and so that's just trying to make sure that you're trying to limit when issues occur, to limit the impact of those, and then also maybe where customers don't really know there's something going wrong either. And then finally, Cloud Native Java by my friends Josh Long and Kenny Pastani, which actually takes elements from all those books. It's a very modern, it came out I think in 2017, and it also focuses very much on Spring Boot. So you should definitely check out that book. It kind of takes elements from all those, but of course doesn't go quite as much into depth on them as well, and also talks about some newer things like event-driven architecture. All right. So let's actually start getting into these factors. So the first one, and this kind of comes from my experience. So before I became a developer advocate, I was working as a consultant where I was doing a lot of work on helping organizations go into the cloud, and then also a lot of times they were doing microservices as well. And my first one is, you don't have to be microservices to be on the cloud or to even do a lot of modern stuff. Now, this isn't a hot take against microservices, but there is a lot of things to consider. And so these organizations, like, okay, we're going to break apart the monolith, and we kind of determine, like, these are some of the different concepts and interests, like, at this organization. Orders, items, order history, I mean, generic stuff, it's going to vary between whatever organization you do. And so maybe when we're breaking it apart, we're going to say, like, all right, user is going to have control over items and order history, and then order is going to kind of have control over addresses and fulfillment. And so when orders talks to user, then that's how the communication happens. You don't have user directly talking to fulfillment or something like that. But then this is kind of how it's deployed, orders, address, fulfillment. It's kind of going to be maybe one service or instance, and these other concepts are going to be in like another server or region or instance. But then over time, it's like, oh man, for user, well, we need a lot of time to have access to address, and a lot of times maybe we need to have access to fulfillment, and it's kind of the same thing, with items and order history. And so we start kind of like breaking holes through the wall just to have things to talk to each other, because it was just too difficult to work with otherwise. And so really how these things should have been architected was perhaps more like this, where orders has control over items and order history, and user has control over address and fulfillment. Again, this is very arbitrary, but like naturally this is actually how the paths of communication really worked, but it maybe wasn't obvious when you were looking at an org chart, just saying like, we're going to refactor this, and you didn't really go through it all. And then of course maybe actually ended up also like order history needs to talk to the address. And so what we end up here is the distributed monolith. I've been a part of this many times. It's a very frustrating process. And so there's a lot of challenges that come with microservices. And like the first of them is distributed systems have their own emerging problems. So if you have a monolithic application, and it's communicating this way, just every which way, you know, one concept's talking to another concept. While that does pose architectural issues and makes it difficult to maybe refactor and change an application, there's not much of an issue when it comes to performance, because it's all running in the same process, all in the same machine. So if you have user talking to items or something like that, well, that's not a real problem, because it's, you know, it's, as far as within the system's concerned, it's, you know, going right over to the next bit over there to kind of figure that computation out. But when you're actually doing this as a microservice, there is significant performance impacts. You know, when you're making like this, whether this is RESTful or this is an event-driven service, you have the serialization and deserialization from JSON and back, and then you have to have it go over the network to call somewhere and back. That takes up a lot of processing, a lot of resources, a lot of going on, a lot of latency that gets involved in that you wouldn't have within a microservices or a monolithic application. Also, it makes it much harder when you have all these communication lines to change and upgrade the application, because if you have like a dozen different users of a service, you have to then communicate with all those different services whenever you want to make a change to the API, and that just makes it much more difficult to change and process. It's not necessarily easy to do that within a monolith either, but it's a little bit easier because you're deploying as a single unit. So, yeah, there's a lot of emerging problems that you just can kind of cover up when it's a monolith that you can't when you're doing a microservice. Also, a lot of times to do microservices, it's not just a technological change, but an organizational change. You have to have teams that have complete control over the build, design, and deployment. You can't have it to be you just have developers kind of siloed off, DBAs kind of siloed off, operations kind of siloed off. Then it doesn't work. It makes it very difficult to continually deploy and change those applications, because you have to go through a bunch of different checklists to get applications deployed out there. And finally, this kind of goes to my first book I was talking about. You really do need to have a deep understanding of DDD, or domain-driven design, and your domain itself, because that kind of was getting to is that if you don't have those understandings, you're not going to be able to break up your application into the correct services, and you're going to have these communication lines going all over the place, and it's going to run into a lot of performance issues. Also with monoliths, you can use Spring Boot. There's not like a limit to the size of an application a Spring Boot application can be. So if you want to start using Spring Boot, you can kind of maybe migrate your application over to using it. You don't have to, you know, Spring Boot and microservices, they don't have to go together. Spring Boot and other applications just kind of enable a microservice architecture, because you're not spending so much time on project initialization. You can also be, you can also do continuous integration and continuous delivery. Again, similarly, it's like you have to kind of really be doing continuous integration, continuous delivery to be microservices, but it's not like those concepts are intrinsically tied to doing microservices. So that's probably the biggest thing, is you don't have to do a microservice to be on the cloud. That said, there are a lot of benefits to doing microservices, and a lot of this presentation is going to be kind of how can we kind of maybe slowly start breaking apart this application based upon how it's actually being used. So the first thing is kind of going to the observability. When you kind of first maybe start going to the cloud platform, they already offer a lot of services such as monitoring, as well as logging, aggregation as well. So instead of having to spend developer time to redo and rebuild these things, just kind of use what your cloud platform already provides to kind of start getting that information out of there. Efficiency isn't just necessarily in running your applications, but it's also about efficiency and optimization, how you use developer time to pursue or work on features for your application at your organization. Also, so one of the great ways is, even if you're on a monolithic application, you're going to be communicating with other services. At least that's always been my case at every place I've worked at. And so, you know, you have a request come in from like a user that calls to another service, that calls to another service, and of course this is even much more so if you're doing anything resembling microservices. And of course you're probably going to have multiple instances at each level. And of course, it's not going to just be a single user talking to one. You have multiple users and multiple requests coming in. And so at that point, it becomes impossible to understand and trace where a request is actually coming from. Or you could, but it's just extremely difficult. So what you can use, all you can do is just add to your build file Spring Cloud Starter for request tracing, and then or correlation, and then also Spring Cloud Star Zipkin for doing tracing. And so what this is it adds a couple of elements to the headers of request, and then these IDs. So this is a trace ID. This shows like the overall ID that correlates for an entire request through your system. And then this is a span ID, and this is showing how that request is going through that individual service. So you have like this service 1, 2, and 3, and 4, and you can see at the top and bottom there that span ID is the same because that's within the same service, and the same for like service 2, we see it has like the same span ID. So this is a way you can understand how this request is being processed within your application. And you can kind of see then how things are actually behaving in the real world to kind of determine how things should be changed. Also, there's request tracing, and tracing is a way for being able to time an application to see how it's being used, and this can be a great way to see where you should spend time optimizing an application. So, and this came from Google. It's called Project Dapper. It's a white page. It's like only about a dozen pages long. It's actually a really interesting read as far as these white papers go. So maybe something to kind of also check out for reading it as well. But anyways, if you're looking at how to optimize your application, time would be really well spent, so you can't really see, it doesn't really matter too much, but like here, a lot of time is being spent on a select call to the MySQL database. So finding ways to optimize that select call is going to have a pretty dramatic impact on how long that request takes. Whereas spending time on how your that connection gets set up to that database, even though there's 3 or 4 that times that MySQL connect being called, even if you completely zero that time out, that's going to have almost no impact on the total time of that request. So yeah, this tracing and correlation can tell you where you should be spending time on optimizing. For, again, observability, you can use and customize Spring Boot Actuator. So Spring Boot Actuator gives you a bunch of different endpoints, health, info, metrics, and now they actually offer a Prometheus endpoint. So earlier when I was talking about how your platforms can offer observability and built-in services, that was a Prometheus dashboard, or is Grafana talking to Prometheus, so it can kind of just automatically generate these metrics so that you can easily read them with a lot of standard services out there. There's also configuration props, so you can see what actual configurations are actually being used by your application, and there's a whole lot more besides that. And you can kind of see that here at that link. But you can also customize your endpoints. So like health can be customized. So by default, it's going to scan for data sources and caches to determine the health. And that may not always be enough. I mean, sometimes it is, but it may not always be. So you may also need, like your service may have another service that depends on downstream, that if it's down, it should be considered down. I was actually reading or listening to an interesting podcast this morning talking about observability, and actually the person being interviewed was kind of talking about how a lot of organizations don't do good health checks, and this is kind of the exact thing he was talking about, where they have a service that is heavily dependent on a downstream service to the point to where if that downstream service is down, it should be considered down. So, you know, it's going to vary what dependent services or how your health checks will work, but you can customize it and change it just to make sure you can give a proper profile of the actual health of your application. So, you know, that kind of covers a good amount of the observability. So let's talk a bit maybe about resiliency. And a lot of this can also kind of come from how we're getting observability out of the application to determine maybe areas we need to kind of improve resilience. Maybe like, oh, okay, this is how things are crashing. So one area that a lot of organizations kind of have trouble with is overutilization of downstream resources. So you can use pools to kind of meter resource usage. And so we have like this service, and it's talking to the database, and it's just getting really heavily loaded, and it keeps making more and more and more requests to this database. Eventually that database runs out of threads or processes that it can actually do. Maybe it completely locks like all the tables in a database, and so it goes down. And because it goes down, then the upstream service goes down. So now you have two services you have to restart and get going again, and that just makes things obviously more difficult for you. So instead, what you can do is use pools to kind of meet your resource usage. So here we're making a bunch of calls, and then maybe at like 5 or 6 calls, of course, you can kind of determine this, again, based upon the observability as to how big these pools should be. At that point, you can start either rejecting requests and just saying, hey, come back later to the client, or you can also maybe put them into a queue that says, okay, we're going to put them in a queue maybe for like 30 seconds, and maybe after 30 seconds, you'll kick them out or something like that. But at least you kind of give that downstream resource then time to catch up with the current load. But now, instead of having your database go down or downstream service go down, they're staying up. So your clients are going to be a little bit happier, not going to be having to spend a bunch of time doing restarts. Also, another concept for resiliency is using circuit breakers. And this can kind of help limit what's called a cascading failure, which is kind of similar to what I was talking about before, where, okay, your downstream database is, it just crashed or it was just down for maintenance or something, and so your upstream service just starts calling it and calling it and calling it, and eventually it crashes. I actually literally ran into this issue at a previous organization where I had an application that was calling out to a database, and the resource pool that I was using, it wouldn't throw away bad connections, and so after like 5 or 6 connection calls, it would just crash down. And eventually I found out what was going on, at least what was specifically causing the failure was the DBAs were bringing the database down for maintenance. But of course, really the real problem was that my application wasn't set up properly to actually properly throw away those connections. All the same, what it meant was that this database would go down, it would have to be brought back up, but then my application would also have to be restarted because it wouldn't get rid of those connections. So that's kind of an example of having a cascading failure. Now we had to restart 2 services instead of just 1. So one way that could have been limited is with a circuit breaker. And so if that database was down, instead of trying to make a call that's just going to fail, you can just send it back and do a fallback behavior. And this fallback behavior, again, it's going to vary very much depending upon what your organization has, what would make sense. For example, if you're doing like a movie service like Netflix, their fallback behavior could be, instead of doing like a personalized, hey, here's the kind of movies or TV shows you would like, maybe something is wrong in that personalization service, and so it falls back and just says, okay, here is a list of popular movies that that you may enjoy, that overall they see as popular but may not be necessarily based upon your personal taste. And so for a customer or a client, you may not really notice much difference between that or how the application would normally work, because maybe you just like popular movies anyways. So that's a way of kind of limiting a cascading failure, but also kind of giving a good experience to the client. And also at the end of the day, I would much rather get an immediate 500 error response or just immediate error rather than waiting for 30 seconds for a process that this is going to fail eventually anyways. And beyond that as well is that when you're doing that, that's 30 seconds in which that connection is being opened. That's also taking up resources on your system as well. So there's benefits both to your customer as in usability, but then to your organization itself in freeing up resources, again, to prevent those cascading failures. So maybe getting a little bit to resiliency, but also to scalability, is being stateless can kind of help in both areas. So by being stateless, you're not holding state about information on the individual systems. You may be kind of persisting it back to the database, or it's actually entirely within the request, the current state of where the user is located or the client's located. So that way you can easily add new instances as demand increases, and you can also throw away instances as demand goes back down. But also, if instances just catch on fire for some reason, then you can just seamlessly just transition that customer to call another instance, and they don't know that the other instance, or they are calling a different instance now. So that can be very helpful by being stateless when possible. Granted, you're not going to always be able to do that, but generally a lot of times you can probably be able to actually set up a stateless service if you put some thought into it. So for testing, so one of the things I really like to talk about is automated testing. My previous presentation was actually on JUnit 5, and that's also a big way I got into automation. So one of the most difficult areas, so like when you're doing automated testing for unit tests, that's generally pretty easy because you're kind of testing everything within your own application. You can effectively do it locally. Where things can get a bit more difficult though is when you try doing integration testing. And so a big area with that is maybe RESTful calls to other services. And so a lot of organizations I worked at before, this integration testing would be done by calling a live service, perhaps in development. And so if that service was up and everything was going, well, okay, we would get a green check back and everything works and we're all happy. But sometimes that service would be down for configuration. Maybe they changed the location of it or any kind of different thing. So now when we try to call it, well, that's going to cause that test to fail. But that test isn't failing because any kind of actual programmatic change or anything that the tester is actually really checking for. It's just that the service was down, or maybe there's also issues I've had where like a load test or performance test or just that service is being heavily utilized, and all of a sudden that check or that test that maybe would be executed in half a second now takes like 10 seconds to execute. And when you start adding that all together in a large test suite, you have test suites that then start taking, you know, perhaps hours. I've actually had test suites that take hours to run. And what that does, that discourages from executing that test suite. And of course, also you may have a bunch of failures that have no real relation to what's actually being checked. So you just have failures that are like, hey, you know what, that fail happened, but that's not actually because anything changed, even though maybe sometimes it is. And so you just kind of lose confidence. You don't really care about the results of the test. So you can use Spring Cloud Contract to help with this. And so with Spring Cloud Contract, you can write out contracts. So in this case, I'm showing how to do it for RESTful calls, but it can also be done for messages as well. But you say, okay, we're going to make a post call to this URL bookings endpoint, and we're going to be passing in customer ID, a room number, and then when they're checking in and checking out. And what's also cool with like Cloud Contract is you can have like regex fields, and I think that can be a little bit more explanatory than just maybe putting like a default like fields. Like for customer ID, maybe you put like 1, 2, 3, 4, 5 or something in there. By putting like a regex, you can say, okay, we're expecting it's going to be numeric and it's going to be probably 10 characters long. And also kind of same thing for like this room number, check-in and check-out. You can kind of inform within that with using regexes kind of what the overall format's supposed to look like, and they can also make sure you can do some better boundary checking because you're going to be kind of getting different values every time. But anyways, it's going to be looking for a post that looks something like this, and it's going to have like a header that looks like this, and if that post conforms to this look, then we're going to send back a 201 response saying, okay, this new location was created and it's going to be at this new URL. In this case, I'm showing the successful request, but you can also say, here's what should happen if there's an unsuccessful request. We should send back maybe a 400, and at 400, there should be an error message. So it's not just about showing what's the good behavior, but you can also show what happens when things aren't going quite right. But what this means, though, is instead of calling out to an actual live service, you're just calling out to this mocked up instance, and it's going to succeed, or it's going to, as long as your actual service still conforms to what it's within that request contract, it's going to succeed every time. If you make any change, it's going to fail. And that's going to say, and what this ultimately does, it gives you a lot of confidence in your automated test that when a failure happens, it's because something actually changed as far as programmatically they need to then look into. And also your test should generally run a whole lot faster as well. You're not going to run into some sort of issue where you're going to have like a load test or performance test that's going to all of a sudden slow down your overall integration speed. And also finally, one last thing is that if you're doing like microservices at your if you have a microservice architecture organization, being able to maybe do some running locally, you would have to run a bunch of other services locally, and that could eat up a lot of resources, whereas this, it's not going to eat up a lot of resources because you kind of just mock this all out. So that's also really great for like local testing. Similarly, so contract testing is great for when you're kind of either doing requests or you're doing like a RESTful service or just any kind of HTTP service, or if you're maybe doing some messages. But of course, there's a lot of services and applications and work we do that falls outside of that domain. So for that, you can use something like test containers. And test containers is a library that hooks into the JUnit framework, and it can spin up and tear down a Docker container within the lifecycle of a test. And so that can be great. So instead of the very kind of same concept I was talking about before, instead of having to call out to a dev database where, okay, it's most of the time it's going to succeed, but then maybe the dev database is down, data's been deleted, or any other kind of changes, all of a sudden it fails, and that failure, again, nothing to do with any sort of application change, just, something got misconfigured. Instead, you can, with test containers, is going to spin up a local Docker container, and you can test locally. And of course, you could have done this anyways outside of test containers by setting up like configuring local instances, but that can be very difficult, that can be very resource intensive, and there's also a lot of problems when it comes to being able to actually sync, make sure your local instance is comparable to what's actually in production, whereas where you're doing test containers, you can continually pull down maybe what the most recent Docker image from like your local Docker hub, and you can do that all automatically. You're not going to have to tell anyone like, hey, run this new script to update your local database. That's all going to be within the code of the application itself when you're pulling down from the repository. So all this stuff, all of these kind of just previous two steps is trying to lead to this point to where you can actually have a continuous delivery pipeline to production. So then you can have confidence that your coders can commit to a repository, and then that repository is going to kick off a build in your build server, and it's going to be able to run through all these tests that we've written, and then it's going to deploy out to your cloud, and you have good amount of confidence that those tests are going to run quickly, and when test failures happen, it's because something changed, and so on. And like I said, you just get that confidence from, you have the auditability, you can see all the processes that are going through it, and you have the reproducibility because it's all automated, it's not really manual. And that gives you a lot of more ability to both test and make changes, because you're not going to have to worry, like the cost of making a change is much smaller than it is when you had to do a manual deployments. And also because of the reproducibility is that you kind of know that like, okay, this is the only change we've made, there's no other changes or other factors that could have caused a performance change. So that gives you a lot more ability to both experiment and also a lot more reward for experimenting. But also a really big benefit from doing continuous delivery is it makes it much, much, much easier to keep your dependencies up to date. And something to always kind of keep in mind is this is the code that you kind of write and you have out there deployed in your application, but then this is actually the code your code runs on. And in here, there's going to be security patches, performance enhancements, feature enhancements. So there's this website called shodan.io, I believe that's the name. And what you can do is you can just put in like the URL for whatever place you want to check, and it can show you perhaps all the vulnerabilities that may be going on at that application, or for that URL. Maybe they have like a really old version of Apache they're running, or the app server or something like that is out of date, and then you can say like, oh, this out of date version, here's a script to then get around your security, or exploit like the root password or something. And it's just one of those things that, that's where a lot of your security vulnerabilities are going to probably actually lie, not necessarily in some of the security that you did within your application itself. Not to downplay the importance of securing your application, it's just that a lot more people are using some specific version of Tomcat than how your application is set up, so it's much easier to exploit in that way. And of course, there's a lot of performance enhancements that are also involved. I know, like the Spring team, performance is always a really high priority for them, and actually it's getting even more high priority because all of a sudden we have some of these new frameworks out here like Micronauts and Quarkus that are really kind of also pushing on performance and optimization in that way. So you can get a lot of performance improvements just also from keeping on the most recent version. And finally, I've worked at a lot of places where because deploying was super manual, we would eventually get super out of date on our dependencies, and that's just kind of depressing. You kind of look and see like all this new and cool stuff that's going on out there in the world, and you're like, well, I can't use that because, you know, we're, you know, it's Spring Boot 2.1, but we're still on Spring Boot 1.3. So like all the cool features, like, you know, the animated GIDS in the startup, you know, that's really important in the boot screen. We can't do that in our organization because we're just way behind. So that's also kind of good, and also just kind of builds, keeps morale high for your developers, that they're not feeling like they're being outdated because we're working on really old versions of dependencies. So another thing you can do then,
can you repeat that website?
I think I have a link to it at the end. If not, message me and I'll get that to you. So another thing, it's Shodan, SHODAN.io. That's it. So another thing that's could be pretty easy to do to improve resource usage is by using Eclipse OpenJ9. So has anybody here heard of OpenJ9? Yeah, so OpenJ9, I actually only just learned about it when I first worked with IBM. So OpenJ9 is another version or another distribution of the JVM. And it's actually backed by IBM. And so here is a comparison of memory usage between OpenJ9, Hotspot, Graal, and Amazon Corretto. And it's the exact same Spring Batch application running, and it's just in a bunch of containers running on my local machine. And as you can see, there's a significant less memory usage. It's actually one of the things that, even if I wasn't an IBM employee, I would actually be really interested in talking about OpenJ9, just because you see this significant resource improvement without having to make any changes whatsoever to your application. But one of the great things also is, like I said, you get a great memory savings. You also get the near same throughput. It kind of goes back and forth between Hotspot and OpenJ9, so what's faster, like one release, Hotspot may go a little bit faster, the next release, OpenJ9 gets a little bit faster. But the nicest thing is, it's totally free to use. It's released under Eclipse Public License 2.0, also the Apache License 2.0, so you can just run it on your services, and you never have to pay IBM a dime. It's part of this adoptopenjdk.net, so have people heard of adoptopenjdk.net? So that's also something to really consider with Oracle's recent license changes, is that you can go here and you have access both to OpenJ9 and also Hotspot that are just completely free to use and run within your services. You never have to pay anyone any money. I will say though that if you are running, you know, really big, large organization, you will want to have someone to call. I believe like Stuart or Venkat or someone was kind of mentioned that yesterday during the town hall, that ultimately at the end of the day, you know, if you're a $1 billion organization, being able to get someone on that call immediately when you're running into some sort of organization issue is important. So IBM does offer some support as well for OpenJ9 that you can get. And you can also find out more information there at that link. One other cool feature though that I really like about OpenJ9 is it has what's called class sharing. So within like the standard JVM, you have a class file, and this isn't exactly a great way to store information because you're keeping both stateful information and stateless information all within the same file. So within OpenJ9, it's actually split into both a read-only class and then the class that actually stores state information. So this is completely position independent. Every JVM is going to be kind of building it and looking at it like it this way. And then this is going to be the stateful part that's going to kind of change between JVMs. So imagine you have a bunch of these JVMs. That top part, that's the stateful part, but below, everything there is identical. So instead of having every JVM when it starts up and does all this recompilation, all these re-optimizations, well, we can actually share this information. And this can be done with X-share classes. And if you're running in a non-containerized environment, you can just pretty much do that and you can be done. You can also set the size of your cache as well. Default is like 300 megabytes, which is actually pretty large for this, but if you're maybe having a lot of the JVMs share information, maybe you do need to set it larger. However, of course, many of us, or if you're running in the cloud, you probably are going to be running in the containerized environment. And that first link is actually an article I put together to kind of shows a couple of different strategies as to how you do class sharing when you're in a containerized environment. So like one way is like using like a volume in Docker to save all that information to. Another one is like what's called pre-warming your applications. Anyways, there's a couple different ways. And also that second link is a really great in-depth article by a colleague of mine that really explains what's going on with class sharing. But it's really cool. It's one of the features I think is pretty cool about it. I also know I was reading like another article recently that was talking about method inlining, which kind of comes to optimization within a JVM. And the big thing was like, hey, you don't want to change in this because within like the JVM they were using Hotspot, it doesn't have this feature, but you would have wanted to over-optimize because you're going to cause your JVM to spend a lot of time doing optimizations and compilations. But if you're doing this all before, you can maybe kind of tweak the optimization. Anyways, that's kind of something I've just been pretty interested in. Wrong way. So one really cool thing that Spring has is what's called the cloud config server. So if you're just kind of doing just normal, you have your like application.properties that maybe isn't externally, but every time you make a change to that property, you're going to have to kind of restart your service to be able to read in those new properties. With the cloud config server, you can set up all of your applications to be clients that can talk to that server that then you can periodically check, you can change that. Things like by default every 5 minutes, it'll ping that server to see if there are any changes to properties and then reload those properties into your service. And what this means is it just makes it much easier to maybe change certain things. Like for example, I was talking about request pooling. You're like, okay, what happens if we increase that pool size from, let's say, 10 concurrent connections to 15? How does that impact? Does that improve reliability? Does that improve performance? Or does it degrade it? And because you're not going to have to restart your service or redeploy a service, that just makes it a lot easier to maybe make some optimization changes to it. Also, you can store things a lot more securely, because if you're kind of storing, if you're deploying like the application app properties, if you're putting it all within your code repository, all your application developers then have access to potentially production configuration information, and you don't want that. You can store this information within an encrypted repository, so that way you can keep all your passwords and all that important and sensitive information in a secure location that very few people have access to. Also, one thing is you can tune your Spring Boot application. There's a bunch of different ways you can do this. For one, so by default, you just have everything up in like a jar. You can actually explode out a jar. So like a jar is actually just a zip file that's just called jar at the end, so the JVM just knows it can read that as a Java artifact. But you can actually also explode out that jar that can also have some small improvements when it comes particularly to startup time. You can also review features you're actually using. So I was talking earlier about actuator. Generally you may want to use actuator, but maybe you're not really needing a whole lot. Like, okay, we're pretty good, we feel pretty confident about the overall optimization of our application, so we can just kind of turn it off for right now, and that can have a pretty good impact or performance improvement by not having to constantly send out all those metrics to like another service. And that's also within the application itself, it's not having to do all that behavior. So that can be helpful, again, if you're not actually using that stuff. Also, make sure you're maybe excluding any unneeded dependencies. Spring Boot, one of the ways that it makes developing so much easier is it does a lot of auto configuration. If you have some stuff on class path, it's just going to like, okay, hey, you have batch on class path, maybe you're not using batch or something, but it's going to do a lot of auto configuration behavior based upon that, which is going to load up a lot of classes and stuff like that, which uses memory and increases startup time. By removing that stuff that you're not using, by reviewing and removing it, that's going to have a performance improvement. As I mentioned earlier though, also making sure being on the latest version of Spring Boot. So kind of a lot of the stuff I'm taking this from, there's a great presentation which I linked to by Dr. Dave Sire, who's one of the main platform architects for Spring, and particularly Spring Boot. And there's significant performance improvements between just Spring Boot 2.0 and 2.1, and it looks like they're actually making some more performance improvements again in Spring Boot 2.2. So by keeping current on that, and they're also upgrading their underlying dependencies below that, that can have performance improvements. And of course, it's not Spring and Spring Boot, but keeping current on your database drivers or whatever other dependencies you're using can also have perhaps performance improvements and of course security improvements. There's also tuning in your JVM args, such as like turning on no verify can again have some small amount of performance improvement, and also lazy loading of beans. Don't maybe initially load them up, but kind of wait until they're first used. So one other thing, it may be a bit hard to read this graph, but again, you think of like Spring Boot, and it's like, oh, it's probably actually really memory hungry, and that's just kind of like one of the cost. Like, it's so easy to develop with, but the cost is it's just going to have some higher memory usage. But actually, when Dr. Sire was kind of going through and doing like some of this performance testing, is within like Spring Boot 2.0 on Netty, I think Netty is a little bit better, but like if you're using Tomcat, it's not that big of a difference. He was able to get the like heap size all the way down to, I think it was about 25 megabytes before the startup time just kind of went infinite because it can no longer load up. On Spring Boot 2.1, he was able to get it down all the way to 10 megabytes in size. And so this is like a Spring Boot application that was also using Spring MVC, and it's kind of like had a hello world. So it's a very simple application, but just Spring Boot itself requires very, very little memory to actually work. It's not like a huge memory hog that sometimes it seems like out on Twitter, like people are saying like, oh, Spring has become this super heavyweight thing, and I don't know, that's not correct. Spring has tried to solve a lot of areas, but generally it seems like they've done a pretty good job at keeping things relatively lightweight when it comes to like resource usage. Anyways, I would highly recommend checking out both this blog and then this video that follows all the content within the blog. So it's kind of two different ways to kind of get the same content, whichever you prefer. Another thing you should consider doing is doing A/B testing to tune performance. So sometimes, like traditionally, a lot of organizations, like we've done performance testing in a non-prod region, but that's not a real good way to do performance testing, because in that non-prod region, you're going to be having like more limited resources. How like that physical architecture is set up, like you may have like that database and an application server all physically located in the same location, whereas in like a cloud environment in particular, they may be in like very different physical locations. So that's going to have a real impact on actually that performance testing. Also, the limited resources within a non-prod region can mean you have different bottlenecks. So within your non-prod region, a bottleneck could be memory usage. And so you're like, oh, wait, we're using too much memory. Let's find ways to reduce memory usage. But then actually out in production, your bottleneck isn't memory. It's actually maybe in your software, how many physical connections it can keep open, how many locks it can keep open before maybe it completely locks out the database. And so all that time you spent reducing memory usage had no actual impact on performance improvement, because that wasn't the actual bottlenecks you had in production. So I highly would recommend doing your kind of performance testing in production, and a great way of doing that is with A/B testing, wherein so you may have some instances are configured or designed this way, and some other instances are configured and designed another way. And then you can kind of see from like, you can kind of then test and see like, oh, okay, so setup B is responding a whole lot faster than setup A, so we're going to then propagate that change across all the instances for everyone. And you can kind of do things that way, and you're ultimately going to get exactly what's going on, because you're not going to have to simulate like 100 users all calling concurrently, which may not actually happen at all in production. So you just get ultimately a much better you're getting real-world performance to tune your application. And then kind of finally, the last tip is to introduce chaos into production. Again, with this podcast, the podcast is called Software Engineering Daily, and the most recent episode was on observability engineering, so that's a podcast I'm referring to. But kind of towards the end, they were talking about this developer who was working at Twilio, where they would introduce chaos into production to be able to test whether or not their resiliency strategies are working and whether or not they're getting good observability information out of their application. So like, they would bring down the database and they would say, okay, this is red application here, whatever that might be, does it actually send out information that's saying, hey, I can't connect to the database? What happens then? Does it just crash also when the database goes down, or does it circuit breakers correctly and it still stays up? Maybe it's not obviously performing as well, but it doesn't just go up in flames as well. What happens when this other service goes down here? Does this service also say, hey, I can't talk to this service now? Does it also go up in flames? So ultimately, this chaos, what you're going to do is you're going to have it happen. You're going to have your developers maybe manually go in, or some service or application that may automatically bring stuff down. But you're going to do that while everyone's actually there during the workday, so they're there to be able to actually respond to it. They're not getting calls at 2 a.m. saying, hey, something is down. And ultimately, you're putting things to the test to say, does our application tell us when these things are going down? Does our application respond in the way that we're expecting when it goes down? That's kind of the point. It's putting to the test the things that you think you've done. So to review, you don't have to be microservices to be in the cloud. Use services provided by a cloud to do monitoring. Use Spring Cloud Sleuth for request tracing and correlation. You can use Spring Boot Actuator to also customize. Use pools to meter resource usage. Circuit breakers to limit cascading failures. Be stateless when possible. Use Spring Cloud Contract and test containers for your integration testing. Have a continuous delivery pipeline to production, keep dependencies up to date, consider switching to OpenJ9. Again, kind of to that to the A/B testing point. That could be a great example. Hey, let's have some instances running OpenJ9. Let's have some instances in Corretto. Let's have some in Hotspot, and actually see maybe which ones are performing the best, and then switch to that one as appropriate. Also, class sharing. Cloud configuration to have zero-time configuration changes. Tune your Spring Boot application, A/B testing as mentioned, and then introduce chaos into production. So we have a few minutes for questions, but again, you can find me on Twitter at Billy Crando, or feel free to send me an email or at williamcrando@ibm.com. But thank you so much for your time.